Problem number 1, this is a calculator-aided problem. Here we go. Fish enter a lake at a rate modeled by the function e, given by e of t is equal to 20 plus 15 sine of pi t over 6. Fish leave the lake at a rate modeled by the function L, given by L of t equals 4 plus 2 to the 0.1 t squared. Both E and T are measured in fish per hour, and T is measured in hours since midnight, T equals 0. Okay, so part A says, how many fish enter the lake over the 5-hour period from midnight to 5 a.m.? Give your answer to the nearest whole number. So I'm going to circle a few things here. We want to know how many enter, so I'm just going to be concerned about the enter. We do want to round our answer to the nearest whole number, so we want to be real careful. It doesn't say to round up or round down, it's to the nearest. And then it said how many fish. So I know my units are going to be fish. All right. And I noticed that I'm at a rate of fish entering the lake in fish per hour. So to go from fish per hour to fish, we are going to take the integral. So I'm going to take the integral. It's going to be from 0 to 5. And the entering formula is E of t. So I'm going to write E of t dt. All right, we could actually write that formula in, but if I accidentally write the formula incorrectly, I get a point off. So I'm just going to leave it like that as long as E of t is defined. So if I type that in my calculator, I will get 153.458, and it did say to round to the nearest whole number. So this 3 is going to stay a 3, so that will be 153 fish. This problem was worth 2 points. 1 point for the correct integral setup, 1 point for getting 153. You did not need to write the word fish. So this was worth 2 points. All right, B, what is the average number of fish that leave the lake per hour over the 5-hour period from midnight to 5 a.m.? Okay, a few things I'm going to circle in this one. This said average number, so I know that I'm going to be dealing with the average value formula. And this time we are looking at leaving the lake. And the third thing, this one did not say to round to the nearest whole number, so we do need to leave it accurate to 3 places. So if I want an average value, my formula for average value is 1 over b minus a times the integral from a to b of my function. So on this one, it's going to be 1 over 5. It's going to go from 0 to 5. And this time I'm having the fish leave the lake, so I'm going to use the function L of t dt. So I now have my setup, and hopefully we could just have, I probably would put E of t in as my y1 and L of t in as my y2, because now they're in my calculator. I'm not worried about typing them in incorrectly later as I'm using the problems. And if I type that in my calculator and use math 9, I will get 6.059, and I'm going to leave it to 3 places. So once again, I'm going to get 1 point for this setup, and I'm going to get 1 point for getting that correct answer. So this part would be worth 2 points. All right, part C, at what time t for 0 to 8 is the greatest number of fish in the lake? Justify your answer. All right, when I see a greatest, that to me I know is going to be a maximum. And generally when I see an interval, it's going to be the absolute maximum. Okay, so when we are dealing with absolute maximum, we would like to find the critical numbers, and then we're going to evaluate my function at the endpoints and at the critical numbers. So first thing is, if I'm looking for the number of fish in the lake, the derivative of the fish in the lake would be the rate at which the fish are entering minus the rate at which the fish are leaving. And I would know to find a critical number for this, I would set this equal to 0. So on my calculator, I actually typed in, I let y3 be y sub 1 minus y sub 2, and I only graphed that part of it. So you can actually unhighlight y1 and y2, so only y3 will graph. And when I did that, this is the picture that I got. Something like that. Okay, we obviously don't care about anything before 0, but then I'm looking for this critical value right here. So I use the 0 feature of my calculator. And when I did that, I got t equals 6.204. So that would be my critical number. All right, so the next thing that I would like to try to do, I need to evaluate my function, whatever that happens to be, at my critical numbers and my endpoints. So if I wanted to know, like, what's the change in the number of fish in the lake between that time, it's going to be, and I'm just going to call this, my amount of fish is changing. So my amount is going to be 0 to, we'll just do 0 to t because this stuff doesn't have to go to 8. And it's going to be the amount entering minus, or excuse me, the rate at which it's entering. Whoops, and I need to use a different variable here, dx. So this is my formula that would give me how many fish are changing in during that time interval. Okay, so what we are going to do is I'm going to evaluate, I'm going to set it up as a chart this time. So I'm going to have t and a at t equals 0 is an endpoint, t equals 8 is an endpoint, and 6.204 is my critical value. So what I'm going to do from here is I am going to plug 0 into for my t. So obviously the integral from 0 to 0 is just going to be 0. So the fish obviously aren't changing. The number of fish is not changing. The next thing I'm going to do is plug in 8. And when I plug in 8, I get 80.920. And then when we plug in 6.204, we get 135.015. And again, I'm just typing that right in my calculator, like how it looks. And then from here, if I want a greatest number of fish, the greatest, or it just said at what time t is the greatest number of fish in the lake, that would then be at t equals 6.204 is when there are the greatest number of fish in the lake. And just a couple of comments. This is not telling us how many fish are in the lake. This is just saying how many more are in the lake. So we don't know whether there were 50 there to start with or 100. So this would mean if there were 50, we'd have 50 fish plus 80 more fish. This one would be, we started with 50 fish and we have 135 more fish. So it's obvious that this number is, there's more fish in the lake now. Okay, so that would be my justification for that one. And then we are going to get 3 points for this one. If we set this E of t minus L of t and we set it equal to 0, we showed that that's what we're going to do. We're going to get a point. So just writing what the critical value is not going to get us all of our points. So then if we find that critical value, we do get that second point. And then if we are able to come up with our answer with a table or justification of some sort, we are going to get that third point. Okay, and just a note on this one, if you happen to do it where you were looking for, instead of doing absolute maximum, you did relative maximum instead, they actually are going to give you the points for that as well. So if you would have done, you'd still get the critical number of t equals 6.2024. But if you would have done, I don't even know what to call this, E of t minus L of t. If you would have done plugging in anything before 6.204, you'll notice that that value is positive, and anything after that, that y value is negative. So we could also justify this as saying t equals 0.4 is when there are the greatest number of fish in the lake. We could have said because E of t minus L of t is changing from positive to negative at t equals 6.204. So that would have been another okay justification for us to do. Okay, D. This is a little confusing one. Is the rate of change in the number of fish in the lake increasing or decreasing at t equals 5? Explain your reasoning. So if we want to find whether something is increasing or decreasing, we always take the derivative of it at that time, and then we'll just basically see if our derivative is positive, my rate will be increasing. If my answer is negative, my rate will be decreasing. So the biggest thing is, so we are looking for the rate of change in the number of fish increasing or decreasing. So we need to take the derivative of this, okay? The rate of change in the number of fish is E of t minus L of t. But if I want to take the derivative of that, that would actually be E prime of t minus L prime of t, which means now I need to evaluate at E prime of 5 minus minus L prime of 5. And if you type that in, I believe I got a negative 10.723. And since that number is less than 0, the rate of change, so I'm just going to say decreasing. And then I will say because e prime of t minus L prime of t is less than 0, okay? And I just want to make sure I clarify, why didn't I just do e of t minus L of t or find e of 5 minus L of 5? If the problem would have said, is the number of fish in the lake increasing or decreasing, then I would use the derivatives, which are e of t and L of t. But since it said the rate of change in the number of fish, that's why I had to go an extra derivative. So hopefully that makes sense to you. This was worth 2 points. If you considered e prime of 5 and L prime of 5, that was worth a point, okay? And then if you said it was decreasing and then you were able to offer your explanation, you would get that second point, okay? It would have been okay. You might have written, like, you might have found e prime of 5 and gotten, that would have been negative 6.802. And then if you would have gotten L prime of 5, you would have gotten negative 3.921. You might have said something like, e prime of 5, the number entering is less than the rate at which they are entering is less than the rate that they are leaving, which would mean that it's decreasing. So there's a couple different ways I guess you could say that. So that was worth 2 points. And problem 1 is done.